Hello everyone, video number 2 today. We're going to look at proton NMR. Now I'm going to attach this to the proton NMR work that I've already set, and hopefully I'll help you understand. So remember, carbon NMR was all about the carbon, proton is just about the hydrogens and the different environments that the hydrogens are in. Very similar. The one big difference is the size of the peak on hydrogen NMR also relates to the amount of hydrogens present, and you go into that in more detail in year 13. Where carbon NMR, it just gives us an indication of the environments. The size of the peak tells us how many hydrogens there are. So if we're gonna look at 1, 2, 3, 4 different molecules. Can you make sure you get them nicely now? And it's very similar to carbon NMR, but let's just look at these hydrogens. Now take them as kind of groups. So for example, that there is CH3, that is CH2, that is CH2, that is CH3. So don't think, oh, that's one hydrogen, that's one hydrogen. That is one set of hydrogens. That is another set of hydrogens. That is another set of hydrogens, and that is another set of hydrogens.
So 3, 3, 2, 2.
3, 3, 2, 2, but we've got 4 different sets of hydrogens there. But are they different?
Now, kind of.
Kind of, but kind of not as well.
So the 3 and the 3 ain't different, but the 2 and the 2 ain't different.
But the 3 and the 2 are different. That's all it is. So this CH3 is attached to a CH2. This CH3 is attached to a CH2. This CH2 is attached to a CH3, and so on. So this hydrogen sees that over there. This hydrogen sees that over there. So can you see they're exactly the same? So I'll call that 1 and 1. Now these hydrogens see that CH3 and the H, and this one sees the H and the CH3. So they're exactly the same too. So in other words, on this spectra, we would see 2 peaks on proton NMR. Okay, 2 peaks. Now let's do a little bit more of a complex one. This one here, benzene, we're talking every single one of these hydrogens is attached to a carbon. This attached to 2 carbons. This got also a delocalized electron in there. So every single one of these hydrogens is exactly the same. So you only ever seen one hydrogen peak on a HNMR spectra. Okay. Now this one here. So what have we got? First of all, we got this hydrogen here attached to this oxygen. So that's definitely going to be 1. Then, as you go down, it gets a bit more symmetrical. So these hydrogens are both the same as each other there, and these ones here, and I'll do a little different shape, are both the same as well. And then this hydrogen there, obviously those 3 are combined as well. So let me make sure that this is clear. This hydrogen is attached to an oxygen, and it sees 2 other hydrogens, so this one's going to be on its own. This one is attached to a carbon, this is attached to a carbon, etc. But that one's exactly the same, so you'd see 1 peak there, another peak there, another peak there, and another peak there. That one is the same as that one, that one is the same as that one, that one's different to that one, that one's different to that one, and that one's different to that one. It's just about finding the individual hydrogens, okay? Now we're looking at this last one here. Now let's make sure we get this one together, okay? Remember, put them into groups. CH3, CH2, CH2, and this H on its own. These are all the same, and they're attached to these other 2 hydrogens there, so let's put that one as 1. Is that one the same as that one?
Yes.
You would think so, but it's not, because this one is attached to a CH3 and a CH2, where this one is attached to a CH2 and an OH, so it would be different. Okay, that hydrogen would have more interaction, with the NMR, which, the nuclear magnetic resonance, which I don't know massive amount about. It's more of a physics thing, but it would have a different peak. So this one, 1, 2, 3, 4. This one would see 4 peaks. And then we look at the data sheet again, which I'm sure I printed out. Did I print it out? Oh, I forgot to print it out. Can we pause that video for 1 second, please, my good man?
Action!
Okay, we're back. So I've, on my computer screen, can you show us computer screen, please, Em? I've put the HNMR chemical shifts relative to TMS. Remember, TMF is like the reference point where they put it in a liquid and mix it up, and that's their 0. So what we got here, if we look at this one, look down at this please. That would be CH3, CH3. So we'd see that between 0.1 to 2. This one here, CH2, CH2, next to alcohol groups, we would see that, go back up please, between those two there. So CH2, RR, 1.3. Let's have a look at this one. This H there attached to an oxygen. Well, let's look for that one there. Can you go back up there please? You know, we're talking that one there, 3.3 to 4.3. And you use it on me now, babe. You use it to build up a picture. So HNMR, carbon NMR, very, very similar. Take the hydrogens. If it's a CH3, just take it as a hydrogen attached to a carbon. Don't think of them as 3 individual hydrogens, think of them as 1. We need more practice at this, and that's why I'm putting together some other bits before we move on. So don't think we're just going to leave this. I hope this video has helped you understand the proton NMR. I keep telling me it, babe, okay? I hope this video has helped you understand proton NMR a bit. It's about building up a picture. And the picture will not just use hydrogen NMR, it will use, I don't know, maybe you get a bit of empirical formula data, a bit of hydrogen NMR, a bit of carbon NMR, and you've got to build up a molecule. And that's what we're going to work on. We're going to collate this stuff and start to go, there's a nice big 10 marker question that we're going to master before we move on to the year 13 stuff. I will upload this video now. Let me know if you think it's helping you, okay? And then I will also do one more video where I take the molecule that I put, find the molecule, and we'll work through that one then as well. Okay. Thanks, Em. Oh, you're saying goodbye?
Please leave a like. That'll be greatly appreciated. Press the bell so you get notified when new video is uploaded.